Welcome to The Explainer. Today, we're diving into some incredible research that's been bubbling up in the beekeeping world for years. It's a story about a potentially game-changing solution to a beekeeper's biggest nightmare, and the surprising, frustrating wall it's run into.
So, let's start with a really interesting question, one that kicked off this whole journey. What if one of the best weapons we have against the honeybee's deadliest enemy is a common, bee-safe chemical, one that's actually found naturally in honey itself? And that enemy, the villain of this story, is the varroa mite. If you talk to any beekeeper, they'll tell you this tiny parasite is without a doubt the #1 threat to their colonies. It's just a relentless, destructive force that weakens bees and spreads all sorts of nasty viruses.
Now here's where the problem gets really tricky for beekeepers. It's something called the summer treatment gap. See, during the summer, when the bees are making honey, the mite populations just explode. But beekeepers are stuck. Most of the really effective treatments can't be used then, either because they don't work well in the heat, or worse, they could contaminate the honey. It is an absolute nightmare scenario.
This exact challenge is what sparked a whole new way of thinking. It led to the development of something called extended-release oxalic acid, or OA for short. It was designed specifically to fill that summer treatment gap, to work when pretty much nothing else can.
And this slide really gets to the heart of why it's so different. Think of traditional treatments as a flash flood. You get a big, powerful hit, but it's over in about 3 days. And it completely misses all the mites that are hiding out, reproducing under the protective wax cappings where the baby bees are. But OAE is more like slow irrigation. It's a steady, constant pressure, week after week, that nails those mites the moment they emerge.
So what is this stuff exactly? The key is that it's not just plain oxalic acid. It's a very specific recipe. You take oxalic acid and mix it with food-grade glycerin. Then you soak that mixture into some kind of cellulose matrix, basically a sponge. That's what creates this slow, sustained-release system right inside the hive.
But, getting this method right didn't happen overnight, not even close. It took years of dedicated research by biologist Randy Oliver to figure out not just the right recipe, but, just as important, the absolute best way to deliver it. You can see the evolution right here. The whole thing started around 2015, inspired by some research out of Argentina that used cardboard strips. But that was just way too much work for a big commercial beekeeping operation. So by 2017, the focus shifted to shop towels, much easier to use. But the real aha moment came in 2019 with Swedish cellulose sponges. They could absorb way more of the solution and were just a lot easier to work with. And this table really sums up the horse race. Yeah, shop towels worked, but the bees had a habit of chewing them up and kicking them out of the hive too fast. Cotton pads were just a mess to handle. In the end, 2 clear winners emerged, the Swedish sponges and a similar product called maximizer pads. They both offer that consistent release and, most importantly, they really worked.
Okay, so after all that trial and error, all that fine-tuning, how well did it actually perform out in the real world? Let's take a look at what the big field trials showed.
The results were, they were dramatic. In trials that ran for about 55 days, colonies that started with scary high mite counts saw those numbers just plummet. We're talking about a time of year when mite populations should have been skyrocketing, and instead this treatment just knocked them flat.
Just how good was it? Let's put a number on it. In the 2022 trials, the Swedish sponge method got a 91% absolute reduction in mite counts. And that term, absolute reduction, is super important. It doesn't just mean the mite count was 91% lower than an untreated hive. No, it means that 91% of the mites that were actually in the hive to begin with were wiped out. In some hives, it took the mite level all the way down to 0.
And the benefits go way beyond just killing mites. The treatment is gentle on the bees and the developing brood. It doesn't contaminate the honey or the wax. It doesn't care if it's hot outside, and, this is the big one, it works even when the queen is laying and there's lots of brood present. It really checks all the boxes.
So with all these advantages, it's really no surprise that after all those years of testing, Randy Oliver, the lead researcher, came to this conclusion. He said he sees it as a game changer for the entire beekeeping industry. Not just another tool, but a fundamental shift in how they can manage varroa.
Okay, so we've got a cheap, effective, bee-safe solution. Sounds perfect, right? Well, here's the twist. Despite all this success, this incredible treatment has slammed into a massive regulatory wall. And the researcher himself is crystal clear about this. He stresses it over and over again. While he's open with his research, he makes it absolutely explicit that this method is not yet approved by the EPA, and he in no way encourages or endorses anyone using it without the proper permit.
This is probably the most crucial thing to understand right now. For pretty much every beekeeper out there, using this is an illegal application method. See, anytime you change the way a pesticide is applied, even a naturally occurring one like this, it has to go through a very slow, very data-heavy registration process with the EPA. And that's to make sure it's safe for the bees, for the beekeepers, and for our food supply. So for now, it's still officially experimental. So let's just imagine for a minute, what would the future of beekeeping actually look like if, or when, this method finally gets that green light?
Well, the method itself is remarkably simple. You just mix equal weights of oxalic acid and glycerin, you heat it gently until it all dissolves, and then you soak some cellulose sponges in the liquid. Once they cool down, you just place 2 half sponges between the boxes where the bees are raising their young. That's pretty much it.
And this might be the most revolutionary part of all. The estimated cost for the materials is only about $1.30 per hive. Just think about that. This could make effective, honey-safe mite control affordable and accessible for every single beekeeper, from the backyard hobbyist to the huge commercial operations.
Which leaves us with a final and pretty critical question. We have a solution that appears to be cheap, safe, and incredibly effective, all backed up by years of data. So how can beekeepers and regulators work together to bridge this gap? How do we get proven solutions like this into the hands of the people on the front lines, the ones fighting every day to protect our most important pollinators?